Section 9.3, rotations. A rotation of x degrees about point Q, called the center of rotation, is a transformation with the following properties. The image of Q is itself, since Q is the center of rotation. For any other point, such as V, Q to V prime is the same as Q to V originally. So once again, rotations preserve distance, so rotations are also rigid motions. The number of degrees a figure rotates is referred to as the angle of rotation. When we write a rotation rule, we use a lowercase r, followed by the degree of our rotation, and then the center of rotation. Unless otherwise stated, we're going to assume all rotations are done counterclockwise. For this class, we're going to focus primarily on rotations in the coordinate plane. So we're only going to deal with rotations of 90, 270, 180, and 360. And we're going to use some shortcuts to find those rotations. So those shortcuts here, we have for a 90-degree rotation, if you're given the points x and y to start with, to show a 90-degree rotation counterclockwise, all you do is you switch the location of the x and y coordinate, and you make the original y coordinate the opposite sign. For 180, you merely change the sign on both of the points when dealing with the ordered pair. For 270, you switch the x and y's location again, but this time you make the original x value the opposite sign, whether it's positive to negative or negative to positive. And then for 360, it just stays the same. So these are the shortcuts we're going to use to show rotations in the coordinate plane. So for question 1, they've given us PQRS has vertices of 1, 1, 3, 3, 4, 1, and 3, 0. They want to know what the graph of a 90-degree rotation around the origin, that's the O, for PQRS. So in this case, for the most part, we're always going to be around the origin when we're doing our rotations in the coordinate plane. So let's go ahead and plot PQRS. So P is 1, 1, Q, 3, 3. And so this is our shape PQRS. And so we want to conduct a rotation of 90 degrees. So to do that, we have to start with the point we started with. So we know P was 1, 1. And when we do our rotation, we should recognize that since it's 90 degrees, we're going to go from x, y, to the shortcut, which tells us we're going to take negative y, x. So that means P prime in this case should be negative 1, 1. Then we do the same thing for Q. We've got 3, 3. When it becomes Q prime, it's going to become negative 3, 3. For R, we've got 4, 1. For R prime, we're going to bring the 1 forward, make it a negative, and then put the 4 at the back. So it becomes negative 4, 1. And then S, we've got 3, 0, which in this case for S prime is just going to become 0, 3. And so now to show the rotation, we just want to plot these points. So negative 1, 1 is here. So there's P prime. Negative 3, 3. Here we've got Q prime. Negative 1, 4. We've got R prime. And then S prime is 0, 3. And so this is our rotation of PQRS 90 degrees about the origin. It's a 90-degree turn counterclockwise. Question 2, same idea. This time we've got F, G, H, and I, and we're asked to rotate 270 degrees about the origin. So with this one, we'll go ahead and plot the points first so we can see what our shape looks like. Oh, negative 1, negative 1, oops. And there we go. And then 0, 1. So this is our shape. This is our pre-image. So let's go ahead and take care of our transformation. So we're gonna start from our original points, and we're doing a 270 rotation. So the shortcut tells us for 270 we would bring the y forward and make the x negative and move it to where the y used to be. So that means for f with the point negative 3, 2, when we rotate it, it's going to become 2, 3 for f prime. For g, we go from negative 3, negative 1, so it's going to go to g prime, and it's going to become negative 1, 3. For h, we're going from negative 1, negative 1, and it's going to go to h prime at negative 1, 1. And then I, we go from 0, 1, and it's going to go to I prime, which is going to be, in this case, 1, 0. So now we want to plot our image points to show our rotation. So 2, 3, this gives us f prime, negative 1, 3, this is g prime, negative 1, 1, gives us h prime, and then 1, 0 gives us I prime. So this is our new shape, or our image. And so in this case, we can see that we have a 270-degree rotation counterclockwise. Question 3, triangle ABC has vertices of 1, 1, 4, 2, and 0, 4. So let's go ahead and plot these. So 1, 1, 4, 2, and 0, 4. This time they want a rotation of 180 about the origin. So we've got A, B, and C. So this is our triangle, or our preimage. And so now for 180 rotation, that's pretty easy. We go from X, Y, to just changing the sign of both. So negative X, negative Y. So as we go to do our transformation, we start with A as 1, 1, and after the rotation it becomes A prime at negative 1, negative 1. Point B starts at 4, 2. When we rotate it, it becomes B prime at negative 4, negative 2. And then C goes from 0, 4. We rotate it, it becomes C prime at 0, negative 4. So now we just want to plot our points to show our rotation. So negative 1, negative 1, negative 1, A prime, negative 4, negative 2, B prime, and then 0, negative 4 is C prime. And so this is our image after the rotation of 180 degrees counterclockwise. So in the wrap-up, we're looking at using the shortcuts that we saw in order to help us determine the image points for triangle ABC that they gave us, so under each different rotation. So remember, for 270, if your initial point was x, y, you're changing your points to y, negative x. If it's 180, they're just going to become negative x, negative y, or you're changing the signs on both. If it's 90, it's going to be negative y, x, or we change the location, make the y negative. And then a negative 90 rotation. This is the same thing as if you were to think about it, because this negative 90 means we're going to end up going clockwise, but it would be the same thing as a rotation of 270 degrees counterclockwise. So they're the same thing. So go ahead and pause the video, see if you can find the coordinates for your image points, and then we'll check our answers when you're done by unpausing the video. All right, so if you've done it correctly, number 1, you should have gotten A prime as 2, negative 2, B prime as negative 4, 3, C prime is 5, 4. For number 2, A prime is negative 2, negative 2, B prime is 3, 4, and C prime is 4, negative 5. For 3, A prime should be negative 2, 2, B prime is 4, negative 3, and C prime is negative 5, negative 4. For question 4, I didn't feel like writing the answers again because in reality this is the same as number 1. So whatever we got for answer 1 should be the same in 4.